Good morning and good evening, everyone. Based on your time, John, welcome in Salesforce Epics R. And today we are going to talk about getting data out of the Salesforce in the near real time. And our speaker is Patrick. So let me hand over to him.
Hello, everybody. As I said, I'm Patrick, and we're going to talk about getting data out of Salesforce in near real time. Just to give you a little bit of information, my name is Patrick Conley. I'm a principal software engineer at Red Hat. I'm also a Salesforce MVP, and have been working on the Salesforce platform for a little over 10 years now, primarily in our Service Cloud instance at Red Hat. So let's dive straight into what I'm talking about. So let's discuss what near real time means. Because of the nature of the Salesforce platform, the only way you can really have real time in the sense of the word is being on the platform in the database. That's just not something that we're going to be able to do as consumers of the system. When we think real time in the technology and infrastructure, we think of things like the financial services industry, where they want millisecond time for transactions, where things were like trading, milliseconds matter. We're never going to get that with our data in Salesforce, but we can get within a reasonable amount of time. And I also want to say near real time matters depending on what context you're talking about. If you're talking about stuff that is going to a customer where they need to be able to refresh a custom portal, for example, and see the data they just entered, that's going to be a different real time than if you're doing backups or you want something that has to go into a dashboard that gets refreshed every day. That real timeness does come into play. So you need to kind of think that and keep that in mind when you're talking about what your real time data is and why. There's going to be lots of reasons why, and it's going to vary depending on what you're doing with the data. But I can give you some examples that we at Red Hat use. We have a search index that is hosted internally, and we pull the data from Salesforce, and that gets into the search index. We also use that for data for messaging to third-party systems. Such as if we want to alert somebody when a high priority case comes in, or our on-call system on the weekends, that data gets pulled in from Salesforce in real time and sent out to wherever it needs to go. So we're going to first take a look at on-platform options. These are options that are available in Salesforce directly with no other interaction that you have to do other than just have them set up on the platform. One of the granddaddies of all of the ways to get data off the system is going to be outbound messaging. What this does is creates an XML message from anywhere from 1 to 100 messages and makes a post call to an endpoint. These are going to be set up on a specific object. You set it up on the object, you make a workflow, and you send the message, and you include what fields you want in that message. These have some pretty nice pros, to be honest. It's old, but it has an automatic retry. So if your endpoint is down or something happens where the data is not getting shown or not making it, the outbound messaging will automatically retry. And there's no code involved in the Salesforce side of this. This is all just point, click, create workflows, and you're done. The cons are it has no guaranteed order. It will put it into the queue, but it might deliver another message first because of that retry. When it retries, it sticks it back on the back of the queue and the next message goes. So if you have data that has to be delivered in a specific order, think case with a case comment, you want maybe you want the comment to go first and then the case update to go second. That order may not happen. There's no guaranteed timeline. All outbound messaging and all Salesforce says is that it will happen sometime in the future. When that is completely, it could be seconds, it could be hours. We have seen when we do outbound messaging, we've seen where that queue can be backed up by various platform things and have messages delivered hours afterwards. It's not great with large data volumes. Like I said, you can do up to 100 messages at a time. So if you are doing a large transform on data, you have a bulk trigger and you're sending out 1,000 updates to an object, this is only going to cap out at 100 and you're not going to get the rest of those messages. And it's never going to tell you that it didn't send this rest of the messages because it's a limit of 100 messages. You also get no related data. This is only data on a single object. So if you wanted to go back with that case and comments, you can't send comment data with the case message. You can only send case and then you can only send comment. And there's no real strong security with outbound messaging. And what do I mean by strong security? You can use SSL with outbound messaging. There are some caveats about what SSL providers Salesforce, the platform, supports. But for the most part, you can use SSL, but you can't use things like password. You can't use OAuth. You can't have any other authentication. So you have no way of knowing other than this is coming from a Salesforce IP that you are receiving messages that actually came from Salesforce. This may not be a problem depending on what your data is doing, but the security person in me thinks that is a great hole where if I know what the messaging endpoint is and I have no way of verifying that, I could be sending fake messages to it and either corrupting, if you're doing a search index, I can corrupt an index. If you're sending financial data, I can corrupt data, and that's not a great thing to be doing. So outbound messaging works, it's there, but it's probably got a lot of cons that you got to keep in mind. Apex callouts. Now these are going to be REST callouts to an external system made through Apex code. These do allow for a lot more security options, which I'll go to in a second. But this is going to be in a future call in Apex. You make a REST call like you would anywhere else, and you hit your endpoint and you post whatever data you want. The Pro, it's very flexible in its data types. Because it's in Apex, you can pull whatever data you want from whatever related objects you want. You build out your data structure and you make that call to the endpoint. You got a lot more security options. You can use any of the named credentials stuff that the platform supports. You can do any other crazy stuff you want because you can set headers. As long as the SSL layer is supported, you can use whatever SSL provider you want. It's got a lot of security options. Some of the cons are going to be similar to the outbound messaging. And these are no guaranteed order, no guaranteed time frame, and most importantly, no retry. There are some timeout stuff that you can set, but if the endpoint is down, that message will just kind of disappear. And it is very difficult to log failures. Because this is happening in a future call, you can't present that to a user and say, hey, your message never got delivered. There's also governor limits. Some of those governor limits say you can't make a DML operation, then make a call out, then make another DML. So we got to kind of plan your structure appropriately. You can only have 100 call outs and in any given transaction. So you got to be mindful of that and optimize your call outs. The max timeout on an endpoint is 10 seconds. So if you have a large data structure that you're trying to send, or the endpoint you're talking to is slow, you could time out that transaction. And the total transaction time can only be 120 seconds. So again, if you have large data you're passing back and forth and you've got several hops that you have to make to your REST endpoint, and that transaction time extends past 120 seconds, it will just stop it. And then there's future calls. These all have to be made as part of an at future call, which means it happens sometime in the future. Like we said, no guaranteed time frame. There are limits around the number of future calls you can make. You can't chain future calls. Some of the stuff and some of the no guaranteed order can be mitigated by using batch scheduled or queuable Apex, which I'm not going to go into here, but just know that the future stuff, some of it and the chaining can be mitigated with those other Apex options. So when we go to a newer option, that's Salesforce Connect. It's also known as an external data source. The naming around it has changed a little bit. But what this is a supported endpoint, whether that is OData, SAP, some of these other endpoints that they now support. And it shows up as a native object in Salesforce that you can interact with, you can add to list views, you can link to other data. And you can, and like I said, you can interact with it. This is about as real time as you're going to get on the platform because it is making calls to it under the covers and it is making it when the transaction completes. It's not sometime in the future, even though it is technically sometime in the future. It is something that you don't need to worry about because it is Salesforce themselves are handling it. And it's a really low development cost, at least on the platform side. Because you are using Salesforce's platform functionality, you connect to it, and it connects to your endpoint, and there's nothing else that really has to be done on the platform. It is a little expensive. You do pay per endpoint that you use with it, and those endpoints also have limited security options similar to the outbound message. You can still, or outgoing message, you can still use credentials and stuff, but they're not as wide open as with the Apex REST callouts. It is reliant on the endpoint type. So you may not be able to use an existing REST endpoint that you have. You might have to create a new one. And OData can be kind of finicky. I don't know if they have fixed this, but for a while, the Salesforce Connect stuff required the OData endpoint to return some of its data in a very specific order. And if it wasn't there, it would fail. So, you know, it does require some back-end work to get your endpoints ready. But if you're using something that's already supported, or you already have OData available, it might be a good option for you to use. But it does also have limited write capabilities. I don't have these all listed out because honestly, I don't know all of them. But definitely look at the write capabilities for what you need to do before you plunk down the money to buy Salesforce Connect, or at least ask your account executive or your salesperson to say, hey, I'm interested in this. Can you get me a trial so you can try it out first? You can also use Salesforce Connect in the developer instances for one endpoint for free. So you can, that's a good way to test out if Salesforce Connect will work for you. So we talked about the on-platform options. Let's talk about some of the off-platform options. One of the bigger ones is Heroku Connect. Heroku Connect runs in the Heroku infrastructure and allows you to sync data from Salesforce to a Postgres database and back. And that and back is a pretty interesting part because it does allow bidirectional data sync. So you could run Heroku Connect against a Postgres database, and your data can flow from Salesforce into that database. And then you could have something like a custom portal that's running on Heroku that writes data to the database. And whenever Heroku wants to, it will push it back to Salesforce. So that is nice because if Salesforce is down or it's in a read-only mode for an instance refresh or something like that, your data can sit there and collect in Heroku, and then when it's back up, it will push it back over. But again, this is going to be not as real-time because it is using some flow back and forth, and it is expensive. It might be a little bit overkill too, depending on what you're doing, because you do have to have that database connect, that database for Postgres. You're paying for not only the Heroku Connect and the Heroku Dynamo hours, but you're also paying for the database and the database Dynamo hours. But again, depending on your use case, Heroku Connect might be something you want to look into. Now we'll talk about streaming. Streaming will allow you to take data from Salesforce and essentially push it to an endpoint. You define what that data is, and you have a consumer that reads the data in real time. And it's typically using Comment D, which is the technology and the protocol. It will sit there and read your data, and then you do whatever you want with it. If that is, update a search index, or write it to a database, or send an SMS message whenever the message meets certain criteria, that's what you do, and you will do that with the streaming. So there's the first way we're going to talk about is the streaming API. Now, this is one of the older APIs that's available, and you define, I forgot the term, you define your topic for your streaming API as a SOQL query, and that will take any time the data in the system is updated and matches that SOQL query, it will make that data available to the streaming API. Pros, this is about as real time as you're going to get as well from the off-platform option. You do have message reliability, message durability. And what those means is because it sits in a streaming queue, you can replay back messages. If your consumer dies or needs to be restarted or whatever, you can record what the last message you consumed was. You can tell the streaming API, hey, replay back everything that happened since this message ID, and you'll get all those messages that came in. These should be in order of when they happened. I say should be because if two things happen at the exact same time, it's non-deterministic as to which one will go first. And so, keep that in mind. But for the most part, what happens in order will get replayed in order. And those messages stick around for, I think, 24 hours. So, if you have an outage in your consumer, you got 24 hours to get it back up. In my opinion, that's a pretty reasonable amount of time. If you've got more than 24 hours, you got a bigger problem worrying about than consuming your streaming API. Cons, it's a lot of work. All the work now on this sits on your consumer side. You're having to deal with handling all those messages. You're having to deal with replay. You're having to deal with that durability like I talked about. So you're having to keep track of where you were in that streaming API at all times. And some of the governor limits can be tricky. Primarily, the governor limit that pops to mind here is the length of your streaming query. There's a set limit, and I forgot to write it down, for the length of your streaming query, but if it exceeds that query length, you can't run it. So if you're trying to segment out parts, or you've got some really long field names, and you're trying to return a bunch of them back, you're going to run into those limits. One of the other limits here is that you have to specify the fields specifically that you're going to be returning. So again, if those strings get too long, that's going to be tricky. And if you have to add new fields to your topic, that is not an easy thing to do. You might have to delete your stream, recreate it with delete your topic and recreate it with that new field. So migrating and adding new data to the stream is a little bit tough. Something that came out with the very most recent release, and this wasn't in my slides until like 2 weeks ago because of how new it is, change data capture. This was announced a couple of releases ago and was available in DE orgs, and I honestly didn't think it was going to make it to production, but here we are. What change data capture does is allows you to say, I want to make the data for this object available as for streaming. There's a great trailhead on it. You can go in and see how you do that. But you say, here's my object, and it will stream the data as well as additional data. And what I mean is additional data is it tells you if it was an insert, an update, delete. And if it's an update, it tells you what the data changed, and it sends it in a very nicely consumable way. And again, this is streaming, so it's got the same stuff that the streaming API has with the real time and the reliability and durability. But it is much less reliant on your topics and your SQL queries. So you don't have to worry about those governor limits. And you can add fields to it, and add things to the stream without having to worry about going through the dance of deleting and recreating. One of the cons is there's no related data. So again, with the comment and case option that I was talking about earlier, you'd have to create 2 change data captures, one for case and one for comment, and your endpoint would have to know how to handle both of those. They would have to subscribe to both topics and handle them separately. And that's, again, part of the work that is involved with change data capture is all on the consumer side. Now, the last option is going to be polling, and this is going to be either via REST or SOAP. And that is, you can either use a custom REST API or custom SOAP API to call in and get data back, or you can use the enterprise SOAP APIs or the regular REST APIs and make SQL queries directly and pull it back in. And what it is you're asking the system for the data, getting it back, and then asking it whatever set interval later back for the data. Pros about this, you get exactly what you want. If you're doing it with Apex REST, you can define everything and define your object and provide it back. If you are doing it with the SQL query, you in your consumer say, this is the fields that I want. You can bundle multiple queries together with the Apex. You can, there are ways you can make very complex queries in SQL and get that data back. And this is large data ready. If you're using the bulk API, you can get lots of data back with it. It's going to be less real time with the bulk API because you do have to, it is a transaction, you do have to request, wait for it to return and come back. But you can get a lot of data back. Some of the cons, if you're on a smaller org, your API call limits are going to be smaller because you're dealing with, or your API call limits are based on the number of licenses you have. And so you have to keep that in mind. You may not want your poller running every second making API calls if you don't have that many of them. So you got to keep that in mind when setting your poller threshold. The number of records can be interesting because you can get a lot of them back, or you can get none back. And even if you get none back, that's an API call. Date times in Salesforce are stored down to the second. So for a lot of people, this may not be a problem. But if you're dealing with large data that gets updated, within a single second time frame, so let's say your SQL query is saying, give me the last 1,000 that were updated, and you did a large bulk object, bulk update that updated 10,000 records, it will only get those 1,000 for the last second. There are ways to work around this. You can write a trigger that writes down the milliseconds and then make that as part of your query. You can just live with it and know that, hey, if I did a 10,000 record update, I should probably do something different to get my data and update it in my external system. So just keep that in mind if you're writing polling. And then frequency. Like I said, you got to figure out that frequency and that sweet spot for you. Does every second have to happen? And if you're trying every second, does your poll get back and write happen in under a second. Maybe you do it every 5 seconds. Maybe you do it every 5 minutes. You get some flexibility. So this could be a pro because you determine the frequency, but it's also a con because you have to figure that out, and you need to figure out what your business needs are for the real-timeness of said data. So I want to go ahead and talk about some elephants in the room. What about platform events? Well, platform events are a thing that you can use in Salesforce, but they are not a way to get data out. They are a way to write data to an event object, and then they sit around for 24 hours. You probably can use them in conjunction with the streaming API, or you could use them with the polling or one of our other options, but they're not a way to just get data out. And then what about the data loader? Well, the data loader isn't real time in terms of what we're talking about here. You could look at the data loader more akin to polling with using a data loader and data loader script, and that is essentially just polling. It's just using somebody else's code to poll your data. So which one is best? I'm going to leave that up to you as to which one is best, and it's going to all depend on your needs. I will talk about here in a second some of the ways that we at Red Hat use the different options and ways that we get data out, and maybe that'll help inform your decision. But if after all this you have any questions, feel free to hit me up on Twitter, and I will try to help as best I can and help you kind of decide which one you need. So we use at Red Hat 3 different ways of getting data out of Salesforce in near real time. We use outgoing messages, and we use those on our case object, and we push data to an endpoint. And what that really does for us is we're using that as a notification. We're not really using the data in that message other than the ID that came from the case. And then we have a system that goes in and hits a REST API and queries that ID and gets the data and updates things. And that is a nice little balance because we don't have to have a poller for that job to know and to query every second or so, because that record may not have been updated. So we don't care if we get a message, we know that we need to query and we know that we need to update that record. We also use the polling, and we use that on, again, on cases, and we say, give me all the cases that have been updated in the past, 5 minutes or whatever, and we read that data and we do stuff with it. And the one that I think up until Change Data Capture came out, the one that we use the most for our external integrations, so we have some external tracking systems that we need to get data into Salesforce, and we need to get data out from Salesforce to update those external tracking systems. We created a custom object called Outgoing Message. Honestly, it's a terrible name because it conflicts pretty easily with Outbound Messaging. So I would recommend not calling yours Outgoing Message. But what that object has the system that it's going to, the instance of that system. It has what the message or the object is. So in our case, it's sometimes case, sometimes it's comment. And then it has a bunch of fields that allows us to store JSON data in it. I have a couple blog posts about storing JSON data in Salesforce objects if you're interested in that. But it stores JSON data in a known way that our consumer can recombine that JSON data. And what that allows us to do is via Apex and via triggers, we insert the record and we have a polling job that queries for updates to that record and then takes that data and feeds it into our system. and that allows us to make the JSON look however we want. We want to add new fields, we add it to the JSON and we push it out. If we want to add new endpoints or new consumers that we're pushing data to, we create new JSON and we create a new in system. And our messaging system that reads those messages from Salesforce, if it doesn't recognize where it's going, it just leaves it alone and drops it. If it recognizes where it's going, it sends it off to its handler in the backend system. For those who care, that's using JBoss Fuse as our messaging system. We have one job that reads data from Salesforce and then pushes it onto the different queues in Fuse, and then those queues have their own jobs that run and read that data and do things with them. So if I were to make this today, if I were to remake any of those systems today, what would I do? What I'd probably do is a combination. I would have that outgoing message object, obviously rename something different, and still use that structure where probably would do that as part of a platform event and push data to the platform event. And then I would use change data capture either on that platform event or maybe just directly on the new object, and use that to stream to our consumer, which will then put the message on the queue and go out to all of the individual message consumers. In my mind, that is going to be as close to real time as you can get with all the flexibility, and you get the security of using the change data capture, because you have to log into Salesforce to access that API, so you know who your consumer is, and you've got all the durability and message reliability that the change data capture gets. So that's how I would do it in today's world. But that's a lot of work to put on to people, and it's a lot of infrastructure to require on the back end for your consumer. So that's all that I've got. If we have any questions, we can open up the lines and I'll try to answer it as best I can.
Thank you, Patrick. If anybody have any question, feel free to unmute yourself and ask a question directly, or you can put the question on the chat window.
Hey, thanks, Samit. Patrick, I had one question for you.
Okay.
Let's proceed. Yeah. So recently, Patrick, we learned about the PK chunking and everything, and we experimented it for 3 million records. It worked quite well for us. But again, as we also use MuleSoft in our system as part of architecture to send the data to NetSuite, do you think that mechanisms like PK chunking are very effective, especially for monthly backups?
Say that last bit again.
So for monthly backups,
yep,
mechanisms like PK chunking, especially when we have something like MuleSoft with us, is it useful, or like having an ESB is better?
Again, that's going to be up to that's. There's a little bit of a loaded question. Backups are a touchy thing. I would say probably having more backups is going to be better than relying on less backups. We don't really use the ESB that we have set up for backups, so I can't say how we would do that. But I would say, honestly, I would do a separate backup that you know is a good one that gets everything and puts it in, instead of relying on messaging for backups specifically, because messages do fail, because order and things may conflict. It's probably better to have a known good snapshot of data rather than relying only on messaging for your backups.
Yep. I think I can agree to that as well, because for what we have seen is ESB takes some 8 to 10 hours for 3 million records at the moment. Thanks, man. Thanks.
Yeah.
There is another question in the chat window from the Tilak. Can we use the mule for the real-time data transfer?
So honestly, I don't know a lot about MuleSoft and what they can and can't do. I would see MuleSoft as if they do something like this, it's going to be probably either polling or it might be using a streaming API. So they're going to just be a different type of consumer of the data using one of these methods. So yes, you can if you want. If they provide real enough time for however you need to use that data, then yeah, by all means, use something like MuleSoft, use one of these other third-party vendors that have the ability to get data out of the platform. This is obviously not, these are not the only ways to get data off, but these are going to be the core ways that even things like MuleSoft and Heroku Connect uses the streaming API or something similar to it on its back end. So you know they're all going to use these same technologies.
There are a couple of more questions in the chat window. You want me to read or you want to read from yourself?
Yes, please. I don't have the chat window up, so.
Okay. So there is one question: which one is the best method for the enterprise data or the large data set?
When I would say what I said at the very end, probably the way that I would go with that would be I would say for large data, probably the polling option is going to be your best because you can get the data you want for the large data, wait for it to come back, do your stuff with the data, and then start another job. So you can set that interval a little bit better, especially when it comes to large data. And the APIs, especially the bulk API, handle large data better than the other on-platform options.
Okay, there is one more question. I have to insert and update millions of data of my Salesforce to the external system. Then which is the best and secure way?
Probably, again, I'd say that the polling is probably going to be the way if you're dealing with millions of records at a time. I would be interested to know why you have millions of records at a time if you're doing real time, because if you are doing something automated that is updating millions of records at a time, might be worth looking at figuring out a way to also automate the update of your backend system at the same time instead of only in Salesforce. But if you're talking about millions of records a day, then there are going to be other options such as streaming API or change data capture that can handle that large data over a day, not a single point in time. But that would be another way to do that. It would all depend on how your data is spread out over a period of time.
Okay. Anybody have any other question? Feel free to unmute yourself and ask a question directly. Okay, no question. That's great. So thank you everyone for the joining. Yeah.
Yeah, sorry, sorry to cut you off.
No
Can I have, again, I don't know, I just wanted some other topic for discussion about the data. So Patrick, you have been working with Salesforce again as a platform from last 10 years. You have seen the evolution altogether. Do you see the solutions like big objects, or what may be the future of data storage in Salesforce? They must be looking at the product invention all the time, right? So evolution, as we have seen, we have now arrived at up to Salesforce Connect, but we have not seen the solutions like Canvas or something like that fly really well. So what do you see next in the Salesforce vision or roadmap? I don't know if that's the topic for this agenda, but just I wanted to hear it from you.
What I would say is, again, depending on what the data you're trying to do with it is. Like, big objects is great, but once they're written, they're immutable. So if you're trying to change things, then that changes what you're going to do with it. I guess I'll kind of cop out and say that's a vague enough question that I'm not certain I can give a real good answer. I think if you're talking about dealing with data from external systems in Salesforce, I personally think the way forward for Salesforce should be more on Connect and getting the price point or the availability for that wider and price point down lower. I understand that it is a lot of infrastructure and a lot of stuff on the back end, and that's why it costs money. But I think that that's the way to do it, is to make it as native to the platform as possible, rather than using something like Canvas or Visualforce with Apex or with REST callouts to get data from external systems. That's the way that I would see, because that allows your end users who may not know or care that this is coming from, let's say, a Jira instance. They may not know or care that it's coming from there, but they're going to be frustrated when they go to try to write a report and see, well, I can see this Jira data on the case page, but I can't write a report on it. If with something like external data or Salesforce Connect, you can make it so your end users have a better experience and access that data.
Thanks, Patrick. I think that helps. That provides a better perspective to us at least. Because we know we have been discussing the data sharing with external systems, especially with partners, okay, within the system itself. Like blockchain has been introduced by Salesforce right now. So we are exploring also data sharing.
Yeah.
And thanks anyways for the better answer.
Okay, thank you everyone, and thank you so much, Patrick, for joining us over the weekend on the long weekend. And thank you everyone for joining us. And we will share the recording on our YouTube channel as well as PPT on our Apex Hour website. So stay tuned and RSVP for our upcoming sessions. And thank you everyone for joining us. Our next session is PayPal integration with the Salesforce. I hope that's quite interesting topic. Go ahead and RSVP for that to get some notification for timing and Zoom link. Thank you everyone, and thank you Patrick for a great session over the weekend. Thank you.
Thank you.